Hello students, as we have discussed about VSEPR theory, which gives the geometry of simple molecules, but that is theoretical explanation. It does not explain them and also it has some limited applications. So to overcome these limitations, two important theories was based on the quantum mechanical principle are introduced. These are valence bond theory, which is commonly called as VBT, and molecular orbital theory, that is commonly called MOT. So in this video, we are going to discuss about valence bond theory. In short, I am saying VBT. Valence bond theory was introduced by Hitler and London in 1927, and it is developed further by Pauling and others. So, this is based on the atomic orbital and electronic configuration. So, let us discuss this theory by considering two atoms of hydrogen, that is A and B. A and B atoms are approaching each other. Let the atom A, that is hydrogen atom A, its nucleus we are considering like Na, and the nucleus of atom B, let it is considered Nb. Since in the case of hydrogen only single electron is present, let the electron of A hydrogen atom is represented by Ea and the electron of B hydrogen atom is represented by Eb. That means A hydrogen atom, its nucleus is Na and its electron is represented by Ea. For B hydrogen atom, its nucleus is represented by Nb and its electron is represented by Eb. As we know that the nucleus is positively charged and electron is negatively charged. So the two atoms of hydrogen, when they are approaching each other, there will be some attractive forces and there will be some repulsive forces. That is, we know that the positively charged nucleus attract the negatively charged electron. So when we look at into the diagram which is given here, that is the hydrogen atom A, the positive charge shows this is the nucleus, and Ea, that is the negative charge which is represented here, that is the electron of hydrogen atom A. So we know that the positive charge will attract the negative charge. So there is a attraction between these two. So that is represented here. And similarly, in the case of another hydrogen atom, that is B hydrogen atom, its nucleus will attract its electron. So that is represented by this arrow. So the hydrogen of B atom attract its electron, that is E negative. Eb, which is represented here. So this is actually called as old force, that is represented in dotted lines. The old force, that is already existing attractive force, that is a attraction between the electron and the nucleus for an atom. That is an old force. But when the two atoms are approaching and when they are coming closer to each other, so definitely what happens? A new attractive force comes here. So what is that new attractive force? When the two atoms are approaching to each other, when they closer to each other, so the positive charge, that is the nucleus of B, that will start to attract the electron of A. Again the positive is attracting the negative, but is the nucleus of one atom attract the electron of other. Similarly here, the nucleus of A atom start to attract the electron of B. So this force is called as a new force here, new attractive force, because this force is existing now when the atoms are closer. So there are two types of forces exist here, that is an attractive forces, that is a old force, that is a force of attraction between the nucleus and its electron, and the new force, that is due to the attraction between the positive charged nucleus of one atom with the negatively charged electron of another atom. That is represented here as old force and new force. Similarly, when the two atoms approaches to each other, there will be some repulsive forces also, because the positive charged nucleus of one atom definitely start to repel the positive charged nucleus of another hydrogen atom. Similarly, the electron of one atom will start to repel the electron of another atom. So there are two repulsive forces here and there are four attractive forces here. So let us mention the forces here. That is the attractive forces here, that is NaEA, that is the nucleus of A with its electron. The nucleus of B with its electron, that is an attractive force. N represent the nucleus, E represent the electron. Similarly, here the new forces which are NaEA, that is nucleus of A with the electron of B. Here nucleus of B with electron of A. So the forces, that is the attractive forces, are here, and the repulsive forces which experience here, that is EAEB, that is electron of one, the electron of other. And A and B, the electron of A, the nucleus of A and the nucleus of B. So there is some attractive forces and there are some repulsive forces. As here there are some attractive forces as well as the repulsive forces. The attractive forces tend to bring the two atoms closer, whereas the repulsive forces tend to push them apart. Experimentally, it was found that the magnitude of new attractive forces is greater than the new repulsive forces. So as a result of this, the atoms actually, the two atoms which is approaching to each other, they become closer and their potential energy decreases. So what we can say from this? Experimentally, it has been found that the magnitude of new attractive forces is more than that of new repulsive forces. As a result, the two atoms approaches each other and the potential energy decreases. So ultimately a stage is reached where the net force of attraction balances the force of repulsion and the systems acquires minimum energy. So this theory is explaining about why it acquires a minimum energy. So this is all about this theory, that is valence bond theory. This theories lead to the explanation of overlapping of atomic orbitals and hybridization that we'll be going to discuss in the next video. So have a nice day.